Coming to the first problem, find the remainder when x cube plus 3x square plus 3x plus 1 is divided by first one x plus 1, second one x minus 1 by 2, and the third one x. So in order to find the remainder, we need to know about the remainder theorem, which is, so the remainder theorem states that when a polynomial p of x is divided by a linear polynomial x minus a, then the remainder is p of a. So let us make use of remainder theorem in order to find the remainders for the given polynomial. So the first one is x plus 1. So I assume p of x is equal to the given polynomial, which is x cube plus 3x square plus 3x plus 1. So by the remainder theorem, we can say that p of minus 1 is the remainder. This is because x plus 1 can be written of the form x minus of minus 1, which is in the form of x minus a, where a is equal to minus 1. By the remainder theorem, p of a is the remainder, which is nothing but p of minus 1. So let us substitute x is equal to minus 1 in the given polynomial, which becomes p of minus 1 is equal to minus 1 whole cube plus 3 times of minus 1 whole square plus 3 times of minus 1 plus 1. Minus 1 whole cube is minus 1 plus 3 times of minus 1 whole square is 1 plus 3 times of minus 1 is minus 3 plus 1, and this becomes minus 1 plus 3 minus 3 plus 1, which in turn becomes 0. Therefore, p of minus 1 is equal to 0. By the remainder theorem, p of 1 is the remainder, that is, the remainder of the given polynomial is 0. Now let us see the second bit, which is x minus 1 by 2, and p of x is equal to so by the remainder theorem, p of 1 by 2 is the remainder. So let us find p of 1 by 2 by substituting x is equal to 1 by 2 in the given polynomial, which becomes p of 1 by 2 is equal to 1 by 2 whole cube plus 3 times of 1 by 2 whole square plus 3 times of 1 by 2 plus 1. This is 1 by 2 whole cube is 1 by 8, and this becomes 3 times of 1 by 2 whole square is 1 by 4, this becomes 3 by 4, and 3 multiplied by 1 by 2 is 3 by 2 plus 1. So in order to add this, let us find the LCM first. 8, 4 and 2, the LCM is 8. So 8 goes in 8 as 1, and 1 multiplied by 1, which is 1, plus 4 goes in 8 as 2, 2 multiplied by 3 is 6, plus multiplied by 3 is 12, plus here the denominator is 1, so this becomes 8, which is 1 plus 6, 7, 7 plus 12, 19, 19 plus 8 is 27, that is 27 by 8. Therefore, p of 1 by 2 is equal to 27 by 8, which is the remainder of the given polynomial. Moving to the third bit, which is x. So the given polynomial p of x is equal to x cube plus 3x square plus 3x plus 1. So the given linear polynomial is x, nothing but we can write it as x minus 0. So by the remainder theorem, the remainder would become p of 0. In order to find the p of 0, let us substitute x is equal to 0 in the given polynomial p of x, which becomes p of 0 is equal to 0 cube plus 3 times of 0 square plus 3 times of 0 plus 1, which is 0 plus 0 plus 0 plus 1. Nothing but it becomes 1. Therefore, p of 0 is equal to 1. By the remainder theorem, the remainder of the given polynomial is p of 0, which is nothing but 1. That is, remainder is equal to 1. Coming to the fourth bit, which is x plus pi. So in order to find the remainder of the given polynomial, let us use the remainder theorem, which is when a polynomial p of x is divided by a linear polynomial x minus a, then the remainder would become p of a. So the fourth bit is x plus pi, and the given polynomial is p of x is equal to x cube plus 3 times of x square plus 3 times of x plus 1. By the remainder theorem, we can say that p of minus pi is the remainder. This is because x plus pi can be written in the form of x minus of minus pi. So in place of x minus a, we have x minus of minus pi, that is a is equal to minus pi, and the remainder is p of minus pi. So let us find the value of p of minus pi. That is equal to minus pi whole cube plus 3 times of minus pi whole square plus 3 times of minus pi plus 1. Minus pi whole cube is minus pi cube plus 3 times of pi square minus 3 pi plus 1. Therefore, the remainder is p of minus pi, which is equal to minus pi cube plus 3 pi square minus 3 pi plus 1. Moving to the fifth bit, which is 5 plus 2x. So this can be written of the form 2x plus 5. So the 0 would become 2x plus 5 is equal to 0, which gives 2x is equal to minus 5, which is x is equal to minus 5 by 2. Now let us substitute p of x is equal to x cube plus 3x square plus 3x plus 1. In place of x, substituting minus 5 by 2, we get p of minus 5 by 2 is equal to minus 5 by 2 whole cube plus 3 times of minus 5 by 2 whole square plus 3 times of minus 5 by 2 plus 1. This gives minus 5 whole cube is minus 125 by 2 cube is 8 plus 3 times of minus 5 square is 25 by 2 square is 4. This becomes minus 15 by 2 plus 1, and this becomes minus 125 by 8 plus 75 by 4 minus 15 by 2 plus 1. By simplification, we get minus 27 by 8. Therefore, by the remainder theorem, p of minus 5 by 2, which is equal to minus 27 by 8, is the remainder of the given polynomial. Moving on to the third problem, check whether 7 plus 3x is a factor of 3x cube plus 7x. So 7 plus 3x is a factor of the given polynomial, which is 3x cube plus 7x, if and only if 7 plus 3x divides the given polynomial 3x cube plus 7x, leaving no remainder. That means when 7 plus 3x is divided by 3x cube plus 7x, the remainder must be 0. So if the remainder is 0, we can say that 7 plus 3x is a factor of 3x cube plus 7x. So first let us find the remainder for the given polynomial. In order to find the remainder, let us use the remainder theorem. So first equate the linear polynomial to 0. We get 3x is equal to minus 7 and x is equal to minus 7 by 3. Next, the given polynomial can be written of the form p of x is equal to 3x cube plus 7x, and substituting the value of x in the polynomial, we get p of minus 7 by 3 is equal to 3 times of minus 7 by 3 whole cube plus 7 times of minus 7 by 3. So on simplification, we get 3 times of minus 343 divided by 3 cube is 27 minus 7 times 7 is 49 divided by 3. 3 goes in 27 as 9. We get minus 343 divided by 9 minus 49 by 3. On simplification, we would be getting 490 divided by 9. Therefore, p of minus 7 by 3 is minus 490 divided by 9, which is not equal to 0. In the beginning, it was said that 7 plus 3x is a factor of 3x cube plus 7x if and only if when 7 plus 3x is divided by 3x cube plus 7x, leaving no remainder. But here we got the remainder, which is equal to minus 490 by 9. So we can say that 7 plus 3x is not a factor of the given polynomial, which is 3x cube plus 7x.